Hey everyone, welcome back to TechOps tutorial. In today's video, we are talking about something very important in Kubernetes, liveness and readiness props. If you ever wondered how Kubernetes know when your app is healthy or when it's ready to take the traffic, this video will clear everything up. We will break it down in simple terms, look at some easy YAML example, and towards the end, I will show you a quick demo so you can see how it works in real life. So let's get started and understand how Kubernetes keeps your application healthy and always ready to serve user. Before we talk about props, let's understand why health checks are important. In real-world application, containers can sometimes crash, freeze, or simply stop responding. And if Kubernetes has no way to detect this, your user will face downtime. So Kubernetes need a smart way to detect unhealthy containers and fix them automatically. That's exactly where props comes in. Think of props as Kubernetes health checks for your pods. They continuously check if your container is alive and if it's ready to handle the traffic. If something goes wrong, Kubernetes takes action immediately, like restarting the container or stopping traffic to it, so your application stays healthy. Now let's look at what props actually are in Kubernetes. Props are basically periodic health checks performed by kubelet. They run again and again to make sure your container is doing fine. Kubernetes uses these props to make two important decisions: when to restart a container and when to send the traffic to the container. There are three types of props. Liveness props. This checks if your container is alive and running properly. If this prop fails, Kubernetes will restart the container. Next is readiness prop. This checks if your container is ready to serve the traffic. If it fails, Kubernetes will stop sending requests to the pod until it becomes ready again. And third, startup prop. This is optional. This one is useful if your application takes a long time to start. It makes sure Kubernetes does not mark your container as unhealthy during its startup time. So each props has a different purpose and together they help by keeping your application stable and responsive. Let's start with the first type of probe, the liveness probe. A liveness probe checks whether your container is actually alive and running the way it should. If this probe fails, Kubernetes assumes something is wrong. Maybe the application is stuck, frozen, or caught in an infinite loop. And when that happens, Kubernetes automatically restarts the container to bring it back to a healthy state. A common example where liveness probes help when an application becomes unresponsive but the process is still running. From the outside it looks alive but it's not doing anything useful. So Kubernetes steps in and fix it. The main goal of this liveness probe is simple: to make sure your containers stay healthy over time. Now let's talk about the readiness probe. A readiness probe checks if the container is ready to serve the traffic. Even if the container is running, it may not be ready to handle the request yet. Maybe it's still starting up, loading the data, or waiting for the database connection. So here what the Kubernetes does. If the readiness probes fails, Kubernetes will remove the pod from the service endpoint. This means no traffic is sent to the pod until it becomes ready again. This is really useful during the application startup or when your application needs some time to warm up. For example, if your application is still initializing or waiting for a dependencies like a database, the readiness probes prevents user from hitting a half-ready application. The main goal of the readiness probe is simple: make sure the traffic only goes to the pod that are truly ready. Now let's look at a quick comparison between liveness probe and readiness probe. This table makes it super easy to understand the differences. First, the purpose. A liveness props checks if the container is alive and still functioning. A readiness props checks if the container is ready to serve the traffic. Next, what happens on failure? If a liveness prop fails, Kubernetes restart the container. But if the readiness prop fails, Kubernetes simply remove the pod from the service endpoints. No traffic will be sent to it. Then we have a typical use case. Liveness props are great for detecting crashes, infinite loops, or deadlocks. Basically, situation where the application is stuck. Readiness props are used during startup delays or when your application is waiting for something like a database or another service. Example, a liveness issue could be a web server stuck in an infinite loop. A readiness issue could be an application waiting for its database connection to be ready. So in short, liveness keeps your application alive and readiness ensure your application is ready for user. Now let's see what actually happens inside a Kubernetes when a props run. This is the internal flow of how Kubernetes handle props result. First, the kubelet on each node runs the prop for your containers. It checks the container and gets a prop result, success or failure. Next, that result is sent to the API server and the API server receives it and updates the pod status in the cluster. Once the pod status is updated, Kubernetes decides what action to take. If the liveness prop fails, Kubernetes restart the container. This helps to fix the situation where the application is stuck or not responding. If the readiness prop fails, Kubernetes does something different. Instead of restarting, it simply removes the pod from the service endpoint. This means no traffic will be routed to the pod until it becomes ready again. So the idea is simple. Liveness failure, restart the container. Readiness failure, stop sending traffic. This is how the Kubernetes keeps your application healthy and ensure user only reach working pods. Now let's look at the three main methods Kubernetes use to check the health of your container. First one is the HTTP GET prop. Kubernetes sends an HTTP GET request to a specific path and port on your container. If the response code is between 200 and 399, the prop is considered successful. This is very common for web application and APIs. For example, checking /health. Next we have the TCP socket prop. This one simply tries to open a TCP connection to a port inside the container. If the connection opens successfully, the container is marked healthy. These props are great for database or backend services where an HTTP endpoint may not exist. And the third method is Exec command prop. Kubernetes run a command inside your container. If the command returns exit code 0, that means success. This is useful when you want to run your own custom health check script. So in simple terms, HTTP prop checks a URL, TCP prop checks a port, Exec prop runs a command. These are the three main ways Kubernetes verify if your container is healthy. Now let's look at simple YAML example of an HTTP GET liveness prop. This is one of the most common prop types used in real application. Here the prop is checking the /health endpoint on port 8080. If this endpoint returns a status code between 200 and 399, Kubernetes consider the container healthy. You will also notice two timing settings. Initial delay second 5. This means Kubernetes will wait 5 seconds after the container starts before doing the first check. Period seconds is set to 10. After that, it will run the props every 10 seconds. This kind of HTTP props is typically used when your application exposes a health endpoint. If your application already provides /health or /status, this is the easiest and cleanest way to monitor it. Next, let's look at a YAML example for a TCP socket readiness prop. In this example, Kubernetes tries to connect to a port 3306 inside the container. If the port is open and accepting the connection, the prop succeeds and the pod is marked ready. You can also see the timing setting here. Initial delay seconds is set to 10. Kubernetes waits 10 seconds after the container start before running the first check. Period second is set to 5. After that, it checks every 5 seconds. TCP props are very common for databases or backend services. For example, MySQL listen on port 3306, and even if the container is running, the database may need a few extra seconds to initialize. So this readiness props helps the Kubernetes to wait until the service is actually ready before sending the traffic. Now let's look at an example. YAML file for an exec command prop. In this setup, Kubernetes runs a command inside the container to check if it is healthy. Here the command is very simple: cat/temp/healthy. If this file exists, the command runs successfully and returns the status code of 0. That means the liveness prop passes and the Kubernetes know that the container is still alive. Below that, you can see the timing setting. Initial delay second 5. Kubernetes wait 5 seconds before doing the first check. Period second is 10. After that, it runs the command every 10 seconds. Exec props are useful when your application can create or remove a file to signal its own health. So instead of checking a port or an endpoint, Kubernetes directly asks the container, "Are you okay?" by running this command. Now let's look at a full pod YAML example that includes both a liveness prop and readiness props. This pod runs a container called web app on a port 8080. The liveness prop checks the /health endpoint. If this endpoint keeps failing, Kubernetes will restart the container. You can see the timing here. It waits 15 seconds before the first check, then check every 10 seconds, and it will restart the container after 3 failures. Next, we have the readiness prop, which uses the /ready endpoint. This one tells the Kubernetes when the app is ready to receive the traffic. It starts checking after 5 seconds and then checks every 5 seconds. Notice how the liveness and readiness props use different paths. This is good practice because alive and ready for traffics aren't always the same thing. Overall, this is a production-ready pod configuration that cleanly separates startup health from a traffic readiness. Before we wrap up props, let's go over the common parameters you will see in almost every configuration. First, we have initial delay seconds. This tells the Kubernetes how long to wait after the container starts before running the very first props. This is helpful if your application needs a few seconds to warm up. Next is period seconds. This controls how often Kubernetes should run the prop. By default, it checks every 10 seconds. Then we have a timeout seconds. This is the maximum amount of time Kubernetes waits for the prop to respond. If the prop takes too long, it's considered a failure. Now let's look at a failure threshold. This tells Kubernetes how many times a prop can fail in a row before it takes action. For example, after 3 failures, it might restart the container. Finally, there is a success threshold. This is the number of consecutive successful checks needed to mark the container as healthy. For most cases, the default of 1 success is enough. This parameter gives you fine-grained control over how Kubernetes monitors your application. Now let's go over some best practice for Kubernetes props. These tips keeps your application healthy and running smoothly. First, use lightweight health checks. Try to keep your props checks simple and fast, like a basic HTTP endpoint or a small command. This avoids extra resource usage and prevents timeout. Next, avoid long running command in your props. If a prop takes too long to finish, it can slow down the container or even block other props. In production, it's better to aim for checks that respond under a second. Another good practice is to combine both liveness and readiness props. Liveness checks make sure your application is not stuck, and readiness check make sure it's actually ready to serve the traffic. Using both together gives you more reliable and resilient application. And finally, use a startup prop for slow starting application. Some application like Java apps takes extra time to boot up. A startup prop prevents Kubernetes from restarting the container too early by giving the application time to initialize before liveness check begin. This simple practice can make a big difference in keeping your Kubernetes workload stable and healthy. Now let's look at some real world situation where props really makes a difference. First, we have a web app that hangs. Sometimes an application freezes or gets stuck in an infinite loop. A liveness prop can detect this and automatically restart the application so it recovers quickly. Next, slow starting application. Some application needs extra time before they are ready. Maybe they load data or warm up caches. A readiness prop prevents Kubernetes from sending the traffic too early so the application can finish its startup safely. Another common case is services that depends on other service like a database or an external API. If those dependency goes down, a readiness probe stops sending traffic to your application until everything is available again. We also have a background workers. These are the process that handles the job or a task in a background. A liveness probes make sure they keep running smoothly and aren't stuck. Then there is a rolling updates. During new releases, a readiness props helps Kubernetes perform smooth and zero downtime deployments by only routing the traffic to a pod that are fully ready. And finally, the result of using the props. Your application become more stable, more resilient and better at healing itself. Overall, you get fewer issues and less downtime. These are just some of the real world scenarios where props makes your Kubernetes application safer and more reliable. Alright, before we jump into the demo, here is the quick plan so you know exactly what we are about to do. In step 1, we will start by deploying a simple application that already has liveness and readiness props configured. In step 2, we will initially break the application just a little so we can trigger a prop failure. And in step 3, we will observe how Kubernetes responds, like restarting the container or stopping the traffic when the application is not ready. And finally, we will look at the pod events to see the prop message and understand why the Kubernetes took those actions. That's the plan. Simple and straightforward. Let's do a hands-on demo to understand the difference between readiness and liveness props in Kubernetes. We will deploy a simple busybox pod that has both props enabled, and then we will intentionally break readiness and liveness one by one to see how Kubernetes react. Let me access the terminal. As you can see on my screen, I have started Minikube server, and also you can see the output of kubectl get nodes. Alright, now let's move on to the hands-on demo. I have created prop-demo YAML file. Let me access that. This is the YAML file I have created. Before we start, one quick but very important note. Props don't react instantly, they follow the timers. Initial delay seconds is 2, period seconds 3 and failure threshold is 1. So readiness will fail and go to 0/1 in around 5 seconds after we break it. Liveness prop timing is initial delay second is 10, period second is 5 and failure threshold is 3. Liveness restart will happen around 20 to 25 seconds after breaking it, so don't expect immediate output. Kubernetes waits based on these settings. So let's deploy the pod. Let's verify kubectl pods-w. As you can see, the pod comes up as 1/1 ready because both files /temp/ready and /temp/healthy exist. First, let's break the readiness prop. This will tell Kubernetes app is alive but not ready to receive the traffic. No restart will happen. Let me open one more tab. Let me zoom it. kubectl exe-it. Give the pod name. I will run /tmp/ready. Here immediately you can see readiness should change to 0/1 in around 5 seconds. Notice something important. The pod is not restarted. The restart state is 0. Only the readiness dropped to 0/1. kubectl describe pod prop demo. Here you can see readiness prop failed. You can also grep it like grep-i and give readiness. In the event you will see the message like readiness prop failed but not restart happens. Here also you can see this is the event of the pod. So let's fix the readiness prop by recreating the file again. Before that, let's see the status. It's still 0/1. kubectl exec-it. Give the pod name. Once you log into the pod, touch /tmp/ready and exit. Now you can see the pod is in ready state 1/1. Now let's break the liveness prop. This time I will delete /tmp/ld file. This tells the Kubernetes app is not healthy. Restart it. This file I am going to delete it. kubectl exec-it prop-demo run rm/tmp healthy. Before running this, let's check the status. It's 1/1 and restart count is 0. So give it a few seconds. It will take 20 to 25 seconds. Let's wait. So you can see the restart counter increased from 0 to 1. This confirms that the liveness props actually restarted the container. Let's understand the time. initial delay is 10 seconds and the period second is 5 and failure threshold is 3, means initially 10 seconds plus 5 seconds into 3 failures is equals to approx 25 seconds to restart. kubectl describe pod prop demo. You will clearly see Liveness prop failed and then back off restarting the container, and this confirms the restart. Readiness prop failed, container app failed, Liveness prop will restart it. In the event section, Kubernetes clearly tells what happens when readiness failed, when liveness failed, and when it restarted the container. Let's see the logs. kubectl logs prop-demo previous. It shows the restarting. This shows the logs from the container before it restarted, which is very useful for debugging real application. In our demo, you will just see starting because our busybox container is very simple and only prints starting before sleeping. But in production, this command would show error message, stack trace or any logs from the last run. Exactly what you need to debug failing containers. So let's fix the liveness. Here you see. Let's fix this. kubectl /tmp/exit. Notice that Kubernetes restart the container once after the liveness prop failed. It does not keep restarting continuously because of back-off timing. Kubernetes waits longer each time before trying again to prevent rapid crashes. As we fix the temp/healthy file, the liveness prop would succeed and the pod would stay healthy. Before we wrap up this demo, here are the key points you just saw. Readiness prop, pod stop receiving traffic when not ready, no restart happens. Liveness prop means Kubernetes restart the container when it becomes unhealthy. The reaction time is readiness around 5 seconds and liveness around 20 to 25 seconds. We verified everything using kubectl get pods -w. That's a live behavior. kubectl describe pod for prop failure and events. That's exactly how Kubernetes keeps your applications healthy automatically. Alright, now let's clean up the resource we created in this demo so our clusters stay clean. Let me run the command kubectl delete pod prop-demo. The status changed to terminating. This may take some time. The pod is deleted. Let's verify. kubectl get pods, no resource found. And that's it. The pod is removed and our environment is clean. Let's move to the slide. Alright, let's quickly recap. We covered two important props in Kubernetes: liveness prop, monitor your container and restart it if it becomes unhealthy. Readiness prop, ensure traffic only goes to the pod that are ready to serve the request. Using both together helps your application fix themselves and keep running smoothly without you watching them all the time. The main benefit is deployments stay stable, downtime is reduced, and Kubernetes handles most of the recovery automatically. In short, props are smart automation for container health. And if you found this helpful, don't forget to like, subscribe, and share it with your teammates. It really helps the channel grow. Thanks for watching TechOps tutorial, and I will see you in the next one.